So in the previous videos, we have seen a lot about regression and also with respect to classifications. Okay, so now we'll get on to another topic known as clustering. So clustering in machine learning or clustering or cluster analysis in machine learning technique, which will group the unlabeled data. So here we'll be dealing with unlabeled data. So it can be defined as a way of grouping the data points into different clusters consisting of similar data points. The objects with the possible similarities remain in the group that has less or no similarities with another group. So that is kind of the bookish definition. So all it does is by finding some similar patterns in the unlabeled data, such as shape, size, color, behavior, etc., and divides them as per the presence and absence of those similarities. Okay, so it is like similar to what we have seen with respect to classifications also, but here it is basically unlabeled data, so you don't have any labels. So that is the major difference. So hence it is unsupervised learning. So till now whatever what and all we have seen is majorly we have almost seen everything as supervised learning itself. So now we'll start up with unsupervised learning. Okay, so it is a supervised learning, hence no supervision is provided to this algorithm, and it deals with unlabeled data. After applying this cluster techniques, each cluster or group are grouped is provided with a cluster ID. Okay, so there will be a cluster ID. So machine learning systems can be used this ID to simplify the process of large and complex data sets. So it will simplify. So again, the cluster technique is commonly used as statistical data analysis. Okay, so somewhere if you just go and hear about statistical data analysis, so that one in the same means as clustering. Okay, so now maybe we'll have some kind of examples to understand better. Okay, so here already pretty straightforward example, right? We have some raw data and then we are clustering it. Okay, creating separate clusters. So to understand with respect to real world example, when we visit any shopping mall, we observe that the things are similar, usage are grouped together. Okay, so maybe with respect to um, type of clothing. Okay, so there are such different clothing sets also, like such as t-shirts are grouped in one, and trousers at the other sections. And similarly, it's not just with respect to clothing. You can find vegetable sections also, apples, bananas, mangoes. So they are all grouped in separate sections, so that we can easily find out the things. Okay, so you can just go in particular section and grab whichever you need. So the clustering technique also works in the same way. So there are so many other examples, like again coming to the real life applications. So basically they are applied in statistical data analysis. The other common like commonly used for statistical data analysis. Okay, so that is what I had told over here. And other thing is market segmentation. So you can segment out with respect to market, and also even social network analysis. So with respect to engaging and also type of groups. So again, those and all will be done with respect to like clusters, which kind of group can we target with different kind of social media activities also. And then we have image segmentations. So again, there are so many apart from these. Again, there are some general cases. Maybe we can take the example of Amazon itself. Amazon, let it be Amazon, and even products like Netflix. Okay, so they do provide recommendation systems. So again, we'll be seeing about recommendation systems later on in the course. So basically, Amazon and Netflix use such techniques to recommend movies or products or web series as per the user. So a very simple example is what we are seeing over here. So we see the raw data coming in and working on a clustering algorithm. So you can see there are different types of fruits divided into several. So basically, let us see types of clustering methods. So here, the clustering methods are broadly divided into hard and soft clusters. When I mean the hard cluster, data points belongs to only one of the group. Okay, so the property will be based on only one of the group. And soft clusters means data points can belong to another group also. Okay, so they have similar characteristics. When you're categorizing some kind of clusters with respect to characteristics. So maybe you wanna do vegetables which are round in shape. So there is so many clusters which will have this character. So like kind of the soft clustering comes into this. So that's not an exact example, but still I think you are getting the idea. So and there is other various approaches also. So like we'll discuss overview of few famous ones, and also we'll deep dive in the couple of them in the upcoming videos. So first thing is partition clustering. So and then we have density based clustering. So again, I'll explain that in detail in a minute. And then we have distribution model based clustering, and we have hierarchical clustering, and finally we have fuzzy clustering. Okay, so first thing is partition clustering. So it is a type of clustering that divides data into non-hierarchical groups. Okay, so basically it is non-hierarchical, so it is opposite for hierarchical, and it is also known as centroid based method. Okay, so it will has the kind of centroids. Okay, so when you're doing clusters, there's something known as centroids. So that's why it is like centroid based. And most common example for partitioning clustering is k-means clustering algorithm, which we will be seeing in detail again in the next one. Over here we'll just get an overview about the partition clustering. So again, in partition clustering, in partition clustering, the data set is divided into sets of k groups. Okay, so k can be used to define the number of predefined groups. Okay, so maybe you want to categorize with by basic instance, you will be having like three groups or four groups or five groups can be easily divided. So you can decide that k groups. The cluster center is created in such a way that the distance between the points of one cluster is the minimum as compared to another cluster with respect to centroids. Okay, so maybe this particular figure will give a lot of insights. Okay, so basically here this is a partition clustering. So you can see we have created partitions with respect to clusters. So again, not considering any with respect to any errors or anything. So here basically we have centroid based method. So basically these are the centroids which you can see, and that is the centroids I was speaking before. The cluster centers is created in such a way that the distance between the data points from one cluster to other cluster is minimum compared to other clusters. So basically, if you just consider this particular data point, the distance between this point to this centroid, this cluster centroid, will be minimum compared to other three. Okay, so that is what it means. So that is about partition clustering. And next we have density based clustering. So in density based clustering, maybe this diagram will give you a lot of more insight. So the density based clustering method connects the high dense areas into clusters. So here you can see it is densely packed, and we have a few white space or gaps in between. So that's why it is like separated with respect to two clusters. Okay, so I think this example is kind of directly having a huge impact with respect to this. But when you're dealing with actual real data set, it will be like this space will be very less, and also there can be 10 thousands or lakhs of data sets. Also, yeah, like lots of data entries with respect to a data set. So highly dense and arbitrary shaped distribution are formed as long as the dense regions are connected. Okay, so any kind of arbitrary shapes are formed. This algorithm does it by identifying different clusters in data sets and connects the area of high densities into clusters. Okay, so the density of the dense areas in data space are divided from each other by sparser areas. So that is what the spaces, the white space what we are seeing over here. So probably if this point is not there, the area would be enlarged like this, right? So that is how the partition will be done. So maybe if you have a couple of more points, you again depends on which density it will be going. So it is again based on some kind of characteristics. So this is actually density based. Okay, so these algorithms can face difficulty in clustering the data points. As I was telling, if you have many points in between, it will be little difficult to verify, segregate. If the data points are like has varying densities and high dimensions, so even multi dimensions is kind of again the difficulty level or the challenges for clustering will be again would be more. And next, I think that's it about density based clustering. And next we have distribution model based clustering. So maybe this diagram will give more insights. So in this distribution model based clustering method, the data is divided on probability of how a data set belongs to a particular distribution. Okay, so the grouping is done by assuming some distribution, so commonly Gaussian distribution. Okay, again, we won't go in much in details with respect to Gaussian distribution. So I think it is one of the distributions. Okay, here the examples we can see, like we have created a Gaussian mixture model. Okay, so basically we have some different circles. So again, they are grouped accordingly. Okay, so even the color hierarchy is telling about that. Okay, the colors with respect to different radius is telling what are the clusters. Okay, so those are the points which will be doing. So again, Gaussian distribution is one of the uh, very good algorithms used for machine learning. And next we have hierarchical clustering. So here basically we are seeing a image of dendrogram. Again, in a minute I'll come about that. So hierarchical clustering can be an alternative for partition clustering. Okay, so about k means I was discussing algorithm, right? So again, similarly, it will be an alternative with respect to hierarchical clustering. So again, we'll have in brief video about hierarchical clustering too. So basically, it is used for partition clustering, as there is no requirement for pre-specifying the number of clusters to be created. Okay, so there is no pre-specification here. You can choose with respect to the color coding or whatever is best fit. So in this technique, the data set is divided into clusters to be created tree-like structure. Okay, so this tree-like structure is known as dendrogram. So basically, here whatever you are seeing at the bottom is nothing but individual data set which are combined from the closest ones. Okay, it is starting from which is the closest one going up to the farthest one. Okay, so it's like once two points are joined, that forms a cluster. Again, that will be compared with another based on distances and all. Again, we'll see with respect to in detail. And last is fuzzy cluster. So fuzzy cluster is a type of soft method in which the data object may belong to more than one clusters. Okay, so the rest all which we all see is hard clusters. So each data set has a set of membership coefficients which depends on the degree of membership to be in a cluster. Okay, so fuzzy, like usually it will be called as fuzzy. K means sorry, C means cluster. Is an example of the type of clustering. So it is sometimes also known as fuzzy K means algorithm. Okay. So again, we won't be concentrating much on that. So basically, again, a bit insights about clustering algorithms. So there are many algorithms. So uh, K-means algorithm is the one thing we'll be seeing. So again, the clustering algorithms can be divided based on the model that we will be using. So there are different types of clustering algorithms published. Only are only a few commonly used. Okay, so there are so many other clustering algorithms which are actually not publicly available also. So again, it depends on the companies whether they want to release or not. So the clustering algorithms is based on the kind of data that we are using, such as like some algorithms need to guess the number of clusters in the given data set, and some does not require with respect to that. It will just find the minimum distance. One is with respect to hierarchical clustering, so it doesn't need any predefined number of clusters, whereas partition you can have predefined number of clusters. Okay. So again, the mainly popular clusters used are k-means, which we'll be seeing. Other than that, mean shift. Okay, mean shift tries to find the dense area in the smooth density of the data points. Okay, so again, it is similar. It is one of the soft. It is one of the soft clusters. Okay, so next is DBS scan algorithm. Okay, so this is it stands for actually density based spatial clustering of application with noise. Okay, so quite a big acronym. So it is an example for again densely based clusters. Okay, so the second type which we discussed. And then we have GMM, so Gaussian distribution. So this is with respect to k-means. Okay, it is an alternative for k-means when k-means is failing. Okay, not the k-means. So whenever it is an alternative, so it is assumed that the data points are Gaussian distributed. Okay. So again, we'll not go in detail with respect to Gaussian distribution. Then we have agglomerative hierarchical clustering. Again, we'll discuss that in hierarchical clustering. So agglomerative hierarchical clustering, or and other one is divisive, if I'm not wrong, performs like bottom-up hierarchical clustering and deceive, deceive, divisive is up-down approach. Okay, so again we'll see even the dendrogram what we are seeing over here is actually bottom up. You can see it, we are starting from bottom reaching up to top. Okay, so it is like pretty straightforward, which will be detail explaining. And finally, affinity propagation. So it is a different from other clustering algorithms. So it also does not require to specify the number of clusters. In this, each data point sends a message between the pairs of data until converges. Okay. So again, no, we won't be dealing with that. So now I think we'll see a few of the applications of clustering. Okay. So where exactly they are used. Like randomly, I have told about where and all they have been used. So here we'll see a bit different one. So it is used in identifying cancer cells. Okay, so the clustering algorithms are widely used for identification of cancerous cells. So the clusters will like take the images of whatever, however is the image captured with respect to blood or with respect to any other organs. Okay, so based on that, the captured data will be given to the machine learning, and it will define what kind of cells they are. Okay, so some particular cells, like one of the classification would be cancer cells. So it will be directly tell us which kind of group is like the class. So over there you will be finding a lot of they are grouped in because. So it actually this kind of application will just divide the non-cancerous data set into different groups. Okay, and search engines are also work on clustering techniques. So again, when I'm telling with respect to examples, it's just not limited to one type of algorithm. So they will be actually using many algorithms. Okay, so that's why sometimes the application might repeat. Okay, but the use of that application in that particular reason will be different. So search engines use also recommendation systems. Even that will come as an example over here. But still, search engine. So basically, what happens in search engine is the search result appears based on the closest object to the search query. Okay, so this is how they are. Like even they are creating objects which are like kind of clusters. So it does it by grouping similar data objects in one group that is far from the other dissimilar objects. The accurate result of the query depends on the quality of the clustering algorithms used. Okay, so next is customer segmentation. So customer segmentation is used in market research to segment the customer based on their choice and preference. Okay, so basically, one best example is when you wanna promote your products to different types of customer. You wanna push mails. Okay, you don't wanna like push all the mails to every single person. So you can have a customized mail based on customer segmentations. Okay, so that would be a very good example. So even if possible, we'll work on customer segmentation with respect to projects. And next, we have in biology again. Clearly, it is like not with respect to cancer cells in biology, usually used for uh, classify different species of plants and animals using the image recognition technique. Okay, so that is what it is used with respect to biology. And next, we have land usage. So in land uses, basically the clustering technique is used in identifying the area of the similar lands. Okay, used in the database. So this is very useful to find that what purpose is the particular land used for. So like all the geography can be just segmenting. Okay, so again, even in maps you won't have a real time image, right? So you can get the satellite image also, but usually it will show greenery, roads, or something like that. So all this mapping, all this graphical, sorry, geographic machines we can use in this with respect to identifying the similar of land. Okay. So I think that is a brief introduction about clustering. So in the next video, we'll be seeing about k-means, hierarchical clustering, and so on.